In this video, we're going to look at 5 problems over the 5.5 worksheet dealing with solving trig equations. We'll be going over problems 5, 6, 7, 8, and 9. So if we look at problem number 5, when we're solving secant squared of x plus tangent of x minus 1 equals 0, we need to keep a few things in mind. First, do we have the same terms? I have a secant, I have a tangent, so I don't have the same terms. So I can't deal with it as is. The next thing I want to look at is I see a square, which tells me two things. It tells me make sure it's equal to 0 for solving, which it is, very helpful. And it also tells me it's a square. I'm probably going to want to look at one of my identities, and that may help me get it into like terms. So if I look at secant squared of x and the Pythagorean identities, I can see that secant squared of x is equal to tangent squared of x plus 1, which is really helpful because now all I have are tangents, my trig ratios, so I have like terms. Very good, I can go from there. It's equal to 0, so what I'm going to do next is combine like terms. Well, the 1 and the negative 1 come together and cancel out. So I have tangent squared of x plus tangent of x equals 0. Now, if you struggle with solving and factoring trig ratios, you need to keep in mind that they are objects. They are no different than factoring. I'll put it off to the side. If I have a squared plus a equals 0. In this case, with a squared plus a, you would just use the GCF. They have an a in common, so I take out an a, and I'd be left with a plus 1. And it's the same with tangent squared of x plus tangent of x equals 0. They have a GCF in common. They have a tangent of x in common. And if I factor that out, I get tangent of x plus 1 equals 0. Now for solving, and we'll go back over to the a squared plus a1, we always set each factor to 0. So a equal to 0, we set a plus 1 equals 0, and that would allow us to solve. And you do the same thing with the trig ratios. We set tangent of x equal to 0, and we set tangent of x plus 1 equal to 0, and we solve. So I can go to my trig chart and look at where is the tangent of x equal 0. And in that case, it occurs at x equals 0 degrees and at x equals 180 degrees. For the next one, what I can do is tangent of x plus 1 equals 0. So I solve for tangent of x, it equals negative 1. And if I go to the trig chart in that case, I can see tangent of x equals negative 1 at x equals 135 degrees and 315 degrees. So the final answer, all angles, and I'll put them in numerical order, is 0 degrees, 135 degrees, 180 degrees, 315 degrees. So the big deal is make sure you can factor with trig ratios, and we're relying on our trig chart to help us figure out each one when we're solving. So that's problem 5. I wanted to go over that one because it involved the idea of GCF. So a lot of the factoring techniques I'm trying to highlight are ones that I think for some reason are important for us to know. So if we look at number 6. Number 6 you may think is nice because we have it equal to 0, that's good, and you may think we have like terms, which is kind of true. They are cosines. Now I'll give you that, but this is a cosine of x. This is a cosine of 2x. They're not the same terms. And so what I have to do is I need to make everything a cosine of x. Not a cosine of 2x, a cosine of x. It could be cosine squared of x, just be cosine of x. And in that case, I'm going to use my double angle theorem for cosine. Cosine of 2x. We had a few formulas for these, a few different ones that we could use to expand. The one I'm going to use for this is the one that is, sorry about that, is going to be 2 cosine squared of x minus 1. And the reason why I'm using that one is because then I get it in terms of cosine of x. I have the same term. So plus 3 cosine of x minus 1 equals 0. It equals 0. I have a squared. I'm going to be factoring. So what I want to do first is combine like terms. So I have a 2 cosine squared of x plus 3 cosine of x minus 2 equals 0. This is our AC method of factoring. And when you do the AC method of factoring, again, it's trig ratios. It might be hard for you to see. So what you can do off to the side is imagine it's just 2a squared plus 3a minus 2. So in this case, what I want is I want something. A times c is negative 4. Something multiplies negative 4 and adds to 3. And that's 4 and negative 1. And so what I'm going to do is I can split. I have 2a squared, do plus 4a minus 1a minus 2. And then I would go for grouping from there. These two, so these two have a 2a, a plus 2. These two have a negative 1, a plus 2. So I'm just finishing off the factoring with the a so you can kind of see what our work should be for the problem. It should look like this. We did our AC method. We found out what multiplies a times c to negative 4, adds a 3. We split by grouping, and then we went through and finished. So in this case, it's going to be the same thing. A times c is negative 4. They add to 3. So what multiplies negative 4 and adds to 3? Well, it's the same ones. 4 and negative 1. And so what we do is I'm going to split the 3 cosine of x into 4 cosine of x minus 1 cosine of x. Now I'm going to leave the 2 cosine squared of x and the minus 2. So if I go, we're right here. And it looks about the same structure. We have a 2, a square term of 4, 2, a square term of 4, negative 1 a cosine, negative 2, negative 1 a variable, negative 2. Looks good. So what I'm going to do is factor by grouping. The first two, those have a 2 cosine of x in common. And that's going to leave me with a cosine of x plus 2. The next two have a negative 1 in common. And that's going to leave me with a cosine of x plus 2. Again, very similar structure. And we'll finish off the factoring. We have a 2 cosine of x minus 1 and the cosine of x plus 2. And again, look at the structure. Very similar to how we would do it as a variable. So if you struggle with trig ratios, just off to the side, factor with an a until you understand the technique you're going to use, and then go back to the trig ratio. So that's the factoring. Still not done. Set each one equals 0. So 2 cosine x minus 1 equals 0. You would add 1, and then you would divide by 2. So cosine of x equals 1/2. Now, I didn't do this in the other problem, but realize all students talk constantly. Is my cosine is positive in this case, which tells me that my angles I'm looking for are in the first and the fourth quadrant. So if I look at where it does cosine of x equal 1/2, that occurs at 60 degrees, which is in the first quadrant, and 300 degrees, which is in the fourth quadrant. Let's set this one up. Cosine of x plus 2 equals 0. Cosine of x equals negative 2. So where on a trig chart is our cosine of x equal to negative 2? And what's very interesting is this is not possible. The cosine of a number has to be between 1 and negative 1, the unit circle. And so since this one's outside of our domain for this, it doesn't work. We have no answers for this factor right here. Our only answers are right here. X equals 60 degrees and 300 degrees. So I wanted to go over that for two reasons. This problem I want to go over because it involved the AC method factor, and it involved one of the factors not having solutions to it. Two important concepts there. So let's take a look now at number 7. And let's see if we can figure out what to do, because this one's a little more complicated at the beginning. Well, all other problems that we've dealt with, all the other problems were equal to 0. And I see I have squared terms, so I know I'm going to have to set equal to 0 at some point, and I might as well do it now. So what I'm going to do is I'm going to subtract 1, which I'll line up with the like term here, and I'm going to add my tangent, my 2 tangent of x, which there is no just tangent of x, so I'm just going to slide it right there. So right now, here's what I have. 2 tangent squared of x plus 2 tangent of x minus secant squared of x plus 2 equals 0. So first thing I did was set equal to 0. That's not too bad. The next thing I do is I can get a common term. I don't want secant squared. And so secant squared, I think we did this in a previous problem, is really tangent squared of x plus 1. But there's a problem. This entire object is secant squared of x. It is this whole thing. And I need to put it in a parentheses, particularly because there is a minus sign in front. So I need to subtract this entire thing, not just one part of it. So I have 2 tangent squared of x plus 2 tangent of x minus the quantity, tangent squared of x plus 1, plus 2 equals 0. So now I have like terms. Let me distribute and try and combine what I can. So I'm going to have a minus tangent squared of x minus 1 plus 2. All right, we're almost at the factoring technique. 2 tangent squared of x minus tangent squared of x is just going to give me 1 tangent squared of x. So I have tangent squared of x plus, there's no like terms, and then negative 1 plus 2 is positive. That was a lot of work just to get equal to 0. But why is this one a lot of work compared to the other ones? Well, it wasn't equal to 0 in the beginning, and we had to get like terms because I saw a secant squared of x there. Then I had to realize I am subtracting it, and I have to distribute that to both terms. So that's a lot to get there, but the process is the same. Once it's equal to 0, we're going to factor and solve. Again, what if I don't know how to factor this? I'll think of like a squared plus 2a plus 1 equals 0. Because that's a lot easier. What multiplies the 1 and adds the 2? Well, 1 and 1. Perfect. I now see the structure for factoring. So I have tangent of x plus 1 times tangent of x plus 1 equals 0. Notice it's the same factoring structure. So each factor, they're the same thing. They're both tangent of x plus 1. So I'm just going to deal with one of these. Tangent of x plus 1 equals 0. So tangent of x equals negative 1. So where on our trig chart is tangent of x equal to negative 1? Well, in this case, I know tangent is negative in the second quadrant and the fourth quadrant for it. So when I go looking for it on the trig chart, I'm going to look in those areas. That would be 135 degrees, and it would be 315 degrees. And there are the values we're looking for. So this one I wanted to go through because it involved a lot of work to getting like terms and getting set equal to 0 for it. The factoring technique wasn't that bad. But the process to get there, we have to remember it's just like a regular equation. Get like terms, set equal to 0, combine what we can, move from there. So now let's look at number 8. Well, this one, sine squared of x, sine of x, I got like terms, that's good. Equals 0, it's equal to 0. Nothing can be combined, so I might as well factor and solve. So factoring. So I'm going to look at it as 4a to the 4th minus 4a plus 1 equals 0. That looks like another AC method. What multiplies the 4? As the negative 4. and that'd be -2 and -2. So what I'm going to do is I'll split the middle term. So I'm going to keep the 4a to the fourth. I'm going to split the middle term into -2a minus 2a plus 1. And in that case, I can continue with factoring by grouping. The first two have a 2a in common. That leaves me with 2a minus 1. The second two have a -1 in common. And that's going to leave me with the 2a minus 1. So I get 2a minus 1 times 2a minus 1. Again, if you just need to do it off to the side until you know, I mean, I did all the way through, but at some point, if you know where to go from there with the trig ratios, stop, and then just start working with it over here. But I wanted to see the whole thing through so we can kind of match step by step to go through. Because it is the same idea. What multiplies the fourth has the -4. And notice, -2 and -2. I'm trying to show you that they're the same techniques for solving. And so what we did is we split the middle term into -2a minus 2a. I'm going to split this middle term into -2 sine of x minus 2 sine of x. And I'm going to keep the 4 sine squared of x, the plus 1. Then we did grouping. The first two terms had a 2a in common. In this case, they have a 2 sine of x in common. And we're left with 2 sine of x minus 1. The next two terms have a -1 in common. We factor that out, we get 2 sine of x minus 1. I mean, look at this. They are step by step the same. So I guarantee you the next one is going to be very similar to 2a minus 1. So 2 sine of x minus 1, and it was 2a minus 1, so 2 sine of x minus 1. Look at that. Same factoring techniques. So in this case, we go through. These are equal to 0. So I get 2 sine of x minus 1 equals 0. And they're both going to be that, so I'm just going to deal with it one time. So I would add 1, and I would divide by 2. So sine of x equals 1/2. Just because it's fun to do, all students talk constant. And sine is positive in the first and second quadrant. So that's going to help me when I go to my trig chart to see when is sine equal to 1/2. That's at 30 degrees, which takes care of my first quadrant, and 150 degrees, which takes care of my second quadrant. So there are my two answers. So why problem 8? I mean, it wasn't as long as the other ones. Again, notice so far 2 of the 4 problems I went over involved the EC method of factoring. Maybe I'm trying to help you see something along those lines for it. I'm starting to now show the all students constantly which quadrants have which trig ratio positive is to allow us to quickly go to our trig charts and know where to look. So let's try the last one, which is number 9. Let's see why we're going to go over number 9 and what's unique about it. So in number 9, what do you notice? First thing I see is it's not equal to 0. I want it equal to 0 and it's not. So that's the first thing I see. The second thing I see is I have a cosine of 2x, which is my double angle theorem. And I have a sine of x. So I don't have like terms. I don't like that. So I want to create them. And what I'm going to do is I'm going to change everything into sines. So if I go to my double angle theorem, and I look at cosine of 2x, and I look for the ones that deal with sines. Cosine of 2x is 1 minus 2 sine squared of x plus sine of x. And I'm going to do something is I know I want it to be equal to 0, so I'm going to subtract 1. It's not going to combine. Right now, I'll just put it minus 1 equals 0. Now let's see what happens. Well, the 1 and the -1, those are going to actually cancel each other out. So I have -2 sine squared of x plus sine of x equals 0. Now, because it's me, I hate factoring. with a negative leading coefficient, what I'm going to do is I'm going to multiply everything by -1, every single term, which really just changes all the signs. And I just find it easier to factor with a positive squared term for it. So how do I factor this? 2 sine squared of x minus sine of x, and I made a slip there. I actually said first 2a, so I meant 2a squared minus a 0. See what I mean is I don't see them as signs, I see them as opposites. So if I do this, and I think about factoring, there's a GCF. They both have an a, and I can factor that out. And I bet you that same GCF factoring technique is going to help us out here. 2 sine squared of x minus sine of x. In fact, it does. They do have a sine of x in common. And if I factor it out, I'm left with a 2 sine of x minus 1. Same structure as what we have there. So now that it's factored, set each one equal to 0 and solve. So I have sine of x equals 0. And if I go to the trig chart, sine of x is going to equal 0 at 0 degrees and 180 degrees. 2 sine of x minus 1 equals 0. I'm just going to do this in one step. You would add 1 and divide by 2. And so based off of the positive quadrants, I know sine of x equals 1/2 occurs in the first and second quadrant. So I bet you that is going to be, for us, 30 degrees and 150 degrees. So I have these angles, and again, just because I can, I'm going to put them in numerical order: 0 degrees, 30 degrees, 150 degrees, 180 degrees. And those are my answers. So why this problem? Well, 2 reasons. It involved factoring with GCF, which I believe this could have been the second or third time we've done this. Somebody tells me second time. So that's kind of an important technique as well. Just we look at the AC method. The other reason why is I think this is the second example as well, dealing with converting a double angle theorem, using our formulas from that. So of the 5 problems I did, I wanted to go over some particular important techniques. I wanted to go over GCF with factoring. I wanted to go over AC method of factoring. I wanted to go over converting with Pythagorean identities and converting with double angle theorems for it. So these 5 are very good to make sure you know how to do when you're preparing for the concepts that are going to be on the test for it.